Hi, Praveen here. In this video we are going to looking at 4-stroke diesel engine. We are gonna run through all the main parts and then I am gonna show you exactly how it was. So before we go too far into explaining exactly how the 4-stroke engine works, let's have a look at some of the individual components. This piston. As you can see we have a piston. This is section here and the piston connect to connecting rod and the connecting rod connects to crankshaft. That is a weird up to down shaped item that stretches from the right side all the way along to left side. The piston itself travel linearly up and down motion. This one, like this, in the combustion space. That is the cylinder. This section. You can see all the edges. You can see on the edge here. There is one side combustion space is here. This one. You can see edge here. That is one side of the combustion space. And here the another side of combustion space where the piston will travel up and down motion. And every time travels down once we refer to as a one stroke, and every time it travels up once it will refer to that also as a one stroke. Although the piston itself is traveling up and down, the crankshaft rotates. So we are converting the up and down motion from the piston into rotary motion. Because of every down motion of the piston and every up motion of the piston translate to one revolution, that is one full rotation of crankshaft. So one stroke up is one revolution the crankshaft. We will have a look at in the moment. Let's have a look at the some of the key components that we needed to see in order to understand how this 4-stroke diesel engine works. The camshaft. Now, as you may have noticed, the 4-stroke engine uses a lot of components, and all of these components need to operate. They need to open and close and move at the correct time in order that the engine can function correctly. In order for this to occur, we are going to use camshaft. A camshaft is a section here, and typically it will run down the side of the engine or perhaps the top of the engine. And the camshaft will control when we inject the fuel into the combustion chamber, when we intake valves open and allow air to the combustion space, and when we open and close our exhaust valve and allow the exhaust gas out of the combustion space. So camshaft is a very important part of the engine because it essentially controls all of the timing of the components. Valves. If you go up to top, we can see we have got a series of valves. We have two valves, one here and one here. You can actually see them a little bit if we look from underneath. Here one valve is another valve. Here is one valve, here is another one. These valves are used to allow air in the combustion chamber and also to allow exhaust gas out of the combustion chamber. So let's have an introduction to 4-stroke single cylinder diesel engine. 4-stroke single cylinder diesel engine is a type of internal combustion engine that commonly used in small vehicles and machinery. It operates on 4-stroke cycle, which includes intake, compression, combustion and exhaust stroke. This engine is known for its durability, fuel efficiency and low maintenance. 4-stroke engines. Now there are 4 strokes per combustion cycle. That means in order to fully end a combustion cycle, the piston is going to need a move down once, up once, down once, up once. That's the 4 strokes. And each of the stroke has a purpose. Let's have a look at stroke 1. We can see we have got a slight blue color here in this space. The blue represents air. When the piston is moving down, and you can see that these two valves have opened. We are now drawing air into the combustion space. Now this air may come from turbocharger or it may just be atmospheric, where we draw air in. But as the piston moves down, it's creating a slight vacuum and is drawing the air into the space. We wanna completely fill the combustion chamber with air because air contains oxygen. There are 3 things we need for combustion, that is heat, oxygen and fuel. So as we draw the air in, we are obtaining oxygen. Now we will see suction stroke. When the piston to move down to what we call the bottom dead center, that is the lowest point of transit within the cylinder lineup. We are now at bottom dead center. We are come all the way down and the piston is as close to crankshaft as it's ever going to travel. That is one of the full stroke and we call the suction stroke or the intake stroke because we are sucking the air into the combustion chamber. Notice now the piston has traveled all the way down and correspondingly. On this section here where it is connected to crankshaft, that is also at its lowest point. Now we will see compression stroke. Now we are gonna push the piston back upward to what we refer to as the top dead center. That's the farthest point away from the crankshaft that the piston is going to travel. The piston moves upward and we are compressing all that air The inlet walls has closed and that's what's allowing us to compress the air. The inlet walls would have closed roughly when we reach the bottom dead center. We compress the air as the piston moves up and we are injecting fuel. You will see that there are some lines coming in here. This is supposed to represent atomized diesel fuel. We will inject the atomized fuel into the combustion phase, and because of the massive increase in pressure, there is also a corresponding increase in temperature. As we compress the air still further, the temperature is going to rise to such a point that the fuel will ignite. Now, because we are compressing air in the second stroke, we refer to this stroke as a compression. So remember, we had suction, that is stroke 1, compression stroke 2, and now we are going on to stroke 3. Now we will see third stroke, that is expansion stroke. It is also called as power stroke. We have finished compressing the air. We get a controlled explosion. The fuel has now ignited within the combustion space. That is represented by this red color, which signifies heat. We have a controlled explosion and the piston is gonna be forced downward. Because of this explosion, there is a huge increase in pressure and temperature, and we are going to force that piston down. And as the piston travels down, it's gonna complete one full stroke. We are now at the bottom dead center again. We can see that on the crankshaft, and the stroke is referred to as a power stroke because that essentially is the stroke that is allowing us to extract the energy that we have got from combustion and turn it into mechanical energy. So the fuel itself contained a chemical energy, and we combusted the fuel. We took that chemical energy and we transferred it into the heat and pressure, and then we use this heat and pressure to drive the piston downwards, and in doing so we converting the energy into mechanical motion. Now, if you could do that, if you could isolate the power stroke without needing the other three strokes, then we would have a very efficient engine. But unfortunately, we cannot do that. Now, combustion chamber is completely full of exhaust gas. We have burned all of the fuel, and what we have is a space that fuel full of exhaust gas. Now, we cannot just inject the fuel into the combustion space at this point because there is not enough oxygen within the combustion space for the fuel to combust. So we need to remove all of this exhaust gas from the combustion space. In order to do that, we will open exhaust valve. Notice we use these two valves to allow air into the combustion chamber. Now we are going to use the other two valves in order to get exhaust gas out of the combustion chamber. So let's watch that occurring now. We completed our third stroke, that is power stroke, and now the piston gonna travel back up to bottom dead center to top dead center. So fourth stroke is exhaust stroke. In this, the piston is moving upward now. Notice the exhaust valve has opened and the exhaust gas is being pushed out past these two valves and into the exhaust gas manifold. Here comes the piston complete strokes, reaches top dead center. The exhaust gas has completely or almost completely exhausted the combustion chamber, and that means we have completed our first stroke, and that was our exhaust stroke. We have completed now one combustion cycle: suction, compression, ignition, and exhaust. That is essentially how a four-stroke combustion engine works. Or if you wanna be really specific, then you can say that is how a four-stroke internal combustion engine works. Now we will see advantages of four-stroke single-cylinder diesel engine. First one is fuel efficiency. Diesel engines are known for their high thermal efficiency, resulting in better fuel economy. Second one is durability. Diesel engines are robust and have a longer lifespan compared to gasoline and petrol engine. Third one is torque. Diesel engine produce higher torque output, making them suitable for application required heavy loads. Now we will see what are the applications of four-stroke single-cylinder diesel engine. First one, it is used in agriculture, where small tractor, harvester, and other farm machinery often use single-cylinder diesel engine. Second one is generator. Portable generator commonly rely on single-cylinder diesel engine for reliable power generation. Third one is marine. In this, small boats and watercraft often utilize single-cylinder diesel engine for propulsion. Now we will see what are the environmental consideration take for diesel engine. First one is diesel engine produce higher level of nitrogen oxide, that is NOx, and particulate matter PM compared to gasoline engine. Second one, modern diesel engine incorporate technologies like selective catalytic reduction and diesel particulate filter to reduce emission. Third one, adhering to emission regulation and using low sulfur diesel fuel can help minimize environmental impact. Now we are at conclusion. That is, it's important to realize that four-stroke engines use a lot more components than two-stroke engines. Small two-stroke engines do not require watts. They do not require push rods. They do not require spring like those we have here, or rocker arm, or camshaft, or any of that. The downside is for two-stroke engine. They have very high power to weight ratio. They are not very efficient. Four-stroke engines are more efficient, but they are weight more. Also, the four-stroke single-cylinder diesel engine offers reliable, fuel-efficient, and durable solution for various applications. Regular maintenance and adherence to emission regulation are crucial for optimal performance and reduce the environmental impact. Third one, as technology continues to advance, diesel engines are expected to become even more efficient and environmental friendly.